FOH-100 Pro G EPON tester is a sharp weapon for FTTH resource management in a vacant terminal ports release. As we know that FTTH GPON or EPON is a passive network, which is low cost and relatively easy to construct but difficult to manage and maintain comparing to active network. In many cases, there are two main problems in FTTH maintenance. Firstly, there are no effective and accurate methods to figure out all the user's information below the OLT, such as how many real online users are after the first splitter or second splitter. What is the corresponding relation between the first splitter or second splitter? What is the corresponding relation between the splitter ports and each user after the splitter? Secondly, we often encounter such a situation when field technician wanted to install new access drop cable for a new user, but he found that there's no spare port on the second splitter, although maybe there are only 5 or 6 real valid users after this splitter. So the question is, how can we accurately find out the vacant split port which is occupied currently? Use a VFL, low efficiency, and you have to knock on user's door and disturb him or her. Or unplug the fiber and just wait for the ONU offline alarm message from network management backstage. Too slow and maybe cause customers complaints due to the internet disconnection. But with the help of FOH-100 Pro G EPON tester, we're able to solve all the problems above high efficiency and accurately. There are several features of FOH-100 Pro tester. And features 1. FOH-100 Pro takes the form of series connection to test. We can see there are 2 optical ports on the top of the tester, and it can be series connected into any point of the FTTH PON network, such as before the first splitter, between the first and second splitter, and after the second splitter. When a tester is series connected into the fiber, the communications between OLT and all ONUs will not be interrupted. Only an instant disconnection and subsequently instant recovery occurs, which is nearly not felt by users. For another word, all users can access to internet as normal during our test. And we know there's another testing mode of termination connection. The tester of termination connection has only one optical port. When this tester is connected to the fiber, all ONUs after the connecting point will be forced to disconnect from the OLT. So, in order to avoid this condition, this tester of termination connection can only do the test after the second splitter, which is low efficiency. We can imagine that it tests the single user's access fiber one by one, while FOH-100 Pro doing a group testing before the splitter efficiently and getting all ONUs information at one time. The other advantage of series connection is that there's no problem of compatibility between OLT and ONUs when a tester connected into network. We might as well think about tester of termination connection. It simulates an OLT itself to communicate with ONU. That brings a problem that it is difficult and even impossible for the tester to make itself compatible with all the existing ONUs from various manufacturers in the current PON network. Once incompatibility occurs, the particular ONU will fail to respond to the tester and establish handshake connection, which will affect and degrade the accuracy of testing. Relatively speaking, the tester of series connection only captures the communication protocol messages between ORT and ONUs to analyze. The original communication process will not be affected or changed. Okay, now we will use the FOH-100PRO to do a group test into a EPON network. As we introduced just before, the tester can be series connected into any point of the network. So we can have a look. This is a first splitter, a second splitter, and 3 ONU. And firstly, I will series connect the tester before the first splitter. Now I turn on the tester. And I will unplug the fiber before the input port of the first splitter. And insert this fiber into the ORT port of the tester. We can see the 1490 power is 4.28 dBm. Use a patch cord to connect the ONU port of the tester and the input port of the first splitter. We can see the G letter flashes. It means that there are ONU registering. So we can see ONU on 2. It means that there are 2 ONU online after this splitter. And if there are only 1 ONU online, we can have a look with the serial number, the password, the PPOE account, and the power level on the screen of the tester. But if there's more than 1 ONU online, we can see this information on our smartphone. Okay, this is my smartphone. And it can be connected to the tester via Bluetooth. Now this is the FOH-100 app. Connect to Bluetooth. And at the back of the tester, there are the Bluetooth MAC address. Okay, I will choose the right address. Okay, now connected. We can see on the screen of my smartphone, there are 3 ONUs. The first is unregistered, and the other 2 is online. And then we can see the serial number, the password, and the downstream and upstream power level. And if there are many ONUs after this first splitter, for example, there are more than 32 or 64 ONUs, and it can all be displayed on the smartphone. Secondly, now we will do a group test before the second splitter. And we strongly recommend to do the test before the second splitter because it is more high efficiency than do the test after the splitter. Okay, now the procedure is the same. Unplug the fiber of the input port of the second splitter and insert it into the OLT port of the tester. Okay, the 1490 problem level is minus 5.32 dBm. And then use a patch cord to connect the ONU port of the tester and the input port of the second splitter. The G flashes. And ONU on too. Okay, now we will do an important job. And while unplug the ONU after splitter, now we can match the splitter port and the right ONU. Okay, connect the Bluetooth. Okay, it's connected. Now, I will unplug the output port of the second splitter. You can see on the top of the screen, there's an offline ONU. And it will show its serial number and a password. And the port is number 4. And we can do a mark. Input a port number 4. Okay, it means that this ONU is connected to the 4th port of the second splitter. Okay, I will reconnect the fiber into the output port of the splitter. Wait a moment, and it shows just on line 1. This ONU is online again. And through this method, we can match all the ONU with the ports of the second splitter. And there's another function of the FOH-100PRO, and the function is a rogue ONU detection. And what is a rogue ONU? A rogue ONU means it will transmit the 1310 nanometer laser continuously or randomly. So it will interrupt other ONUs communicate with OLT, and other ONUs probably will fail to access to internet. So we can use the FOH-100PRO to detect and find out the right rogue ONU. And now I will use a laser source to simulate a rogue ONU. And it will transmit the 1310 nanometer. Connect the laser source into the output port of the splitter. Okay, now there's a ROG-ONU in the network. Connect my smartphone. We can see there's a function of ROG-ONU detection. Switching to ROG-ONU mode. Okay, we can see discover the ROG-ONU. Then I will transfer the transmit mode of the laser. Now, this laser source is simulated with a random transmitted ONU. Also, discover the ROG-ONU. Now I will remove this laser source. You can see on the screen of the smartphone. Okay, there are no errors and no ROG-ONU. And through this method, we can unplug the fiber of the output of the splitter one by one. We can find out which one is the right ROG-ONU. Features 2. The advantages of series connection testing mode have been introduced just before, but there's also an apparent weakness of series connection, which will generate 1 to 3 dB insertion loss. It will result in the weak light ONUs unable to be online. So, what is a weak light ONU? It means its receiving 1490 nanometer optical power is less than minus 26 dBm. So if we would like to do a group testing before the first splitter in the EPON network with poor quality, a large number of ONUs close to the weak light will fail to register to OLT because their receiving optical power might exceed the lower limit due to extra insertion loss. Considering the above problems, FOH-100 Pro develops an innovative connection mode, which is called active series connection. By this technology, when FOH-100 Pro series connected into the network, it not only does not generate insertion loss, but also amplify the 1490 nanometer downstream signal by at least 3 dB. It can ensure all weak light ONUs are online during the test. The accuracy of the test results can still be guaranteed. Later, I will show you the active signal amplification function of FOH-100 Pro. Okay, we have known that the connection mode of the FOH-100 Pro is called active series connection. And by this mode, it will amplify the 1490 nanometer downstream signal by at least 3 dB. So we can do a small experiment. I will connect to the tester after the first splitter. And to show that the 1490 power level is minus 5 dBm. And then I will use a power meter to test the output power level of the O1U port of the tester. Okay, the test wavelength is 1490. We can see the power level is -1 or -2 dBm. So the tester amplifies the downstream signal by at least 3 dB. And then we can see this O1U, and it is a weak light O1U. Besides, this is a fiber attenuator, and it is connected between the O1U and the signal splitter. So now I will test the receive power of the O1U. Unplug the fiber. And the receive power of the 1490 is -27 dBm. Okay, I will reconnect the fiber into this O1U. Now I will series connected the FOH-100 Pro into the line. Connect before the signal splitter. Now I will retest the power level of this O1U. The 1490 nanometer power level is -23 dBm. So the received power is amplified by almost 4 dB. So this O1U will no more be a weak light O1U, and it will make our test more accurate. Feature 3. Now I will focus on the ACE of FOH-100 Pro, the high precision terminal state testing. We know there are always several terminal states of the user's access fiber. For example, vacant fiber, O1U online, O1U offline, and O1U unregistered. And O1U unregistered means this O1U may be invalid, so the OLT rejects its register request. So these 4 states can be summed up as O1U connected and no O1U. This is also the most concerned test requirement when field technicians release those occupied split ports with no O1U connected at terminal. We know the traditional test method is return loss method. The terminal state can be judged by outputting laser to the terminal and checking the returned power. But return loss method can only finish the test on the ideal fiber line or under lab conditions. If there's more than 2 dB loss in the field access fiber, such as a microband and an optical adapter, or there's a little dust on the optical port of the tester, the actual test accuracy is only about 50 to 60%. This is simply unacceptable. Back to the FOH-100 Pro, it adopts the OTDR technology instead of return loss method. FOH-100 Pro can tolerate various fiber loss I mentioned above, and is insensitive to the cleanness of optical port. With the assistance of OTDR technology, FOH-100 Pro can achieve more than 90% accuracy of field vacant split ports testing. By the way, this integrated OTDR is a last 1 km OTDR. Its dead zone parameter also has been optimized. Therefore, if you want to test the quality of the access fiber, the OTDR function of FOH-100 Pro will be a good choice. Okay, next I will show you the specific test functions of FOH-100 Pro. Okay, next we will turn to the terminal state testing function of FOH-100 Pro. And as I mentioned, this function uses the OTDR technology to judge the terminal state of the access fiber. Now I will do some tests for you. And there are two test modes. One is series connection and the other is terminal connection. And the difference of these two modes is that series connection can get the online state of ONU, and the rest are the same. Okay, now I will take my target of this ONU. And this ONU is connected after the signal splitter, and there's an adapter between the signal splitter and this ONU. And now I will use a series connection test mode. And then this is a patch code to insert to the OT port. And I will use a connector adapter. Unplug the fiber of this ONU and insert to the adapter. And now, long press the OPM button. Okay, we can see online displayed on the screen. It means that there's an ONU on the terminal, and this ONU is an online ONU. And then next, I will remove the power cord of this ONU. And then test again. Wait for a moment. And we can see the ONU is offline, but it means that there's an ONU connected on the fiber. And finally, I will unplug the fiber of the ONU, and I will test again. we can see ONU no user. It means that there is no ONU connected on the fiber, so we can release the fiber from this port. And as I introduced just before, if you use a tester of termination connection, and there's some microband or connector inside the fiber, and perhaps you will get a wrong test result. But if you use the FOH-100 Pro and it uses OTDR technology, so most times you can get the right test result. And now I will make a macro band of the fiber. And now I will test again. This too is only a no user. Now I can switch to another mode, termination test mode, and I will unplug the OLT port. And I will long press the ON info button. It displays no ONU. And if you, as I just mentioned, if you use a test of termination connection, and it will use the return loss method to test the terminal state of the fiber. In this condition, perhaps you will probably get a result of there is an ONU, not no ONU. Okay, finally we can have a look about the OTDR function of FOH-100 Pro. The dynamic range of the OTDR is about 7 dB, and its event dead zone and attenuation dead zone is 1 meter and 4 meter. Now we can test the fiber link before this ONU. Now I will connect this link, unplug the fiber out of the port, and connect with the tester. So the real fiber link is 3 meters plus 3 meters plus 10 meters. Now I will connect my smartphone with the tester via Bluetooth. Open the app. Connect to Bluetooth. Okay, connection succeed. I will enter the OTDR function. And then we can just press start to perform the test. Okay, this is the OTDR trace. I will zoom in. Okay, we can see 3 events. The first is 3 meters, second 5.6 meters, and the third 15.8 meters. The result reflects the real condition of the fiber link. So if we want to test the quality of the access fiber before the ONU, we can just use the OTDR function of the FOH-100 Pro to test, and we will get an accurate result of the OTDR trace. Okay, through the above demonstration, I believe you have a more comprehensive understanding of FOH-100 Pro. We hope FOH-100 Pro can bring you efficient work experience, help improving your work quality and saving more time, manpower, and material resources. Thank you for watching this video. Goodbye.